All right. So these expressions might look familiar, something like we just were generating. But let's talk about what we do with limits towards infinity. Remember, we take highest powers from the numerator and the denominator. So highest powers, numerator will be, with its coefficients, will be 81. And then I have an n squared and another n squared. So I get an n to the fourth. Without multiplying out, I see there's an n to the fourth on the numerator. In the denominator here, I see I have 4 n to the fourth. The n to the fourth cancel, so I get 81 over 4. So that's taking the limit. As n goes to infinity. Let's do this one. So limit as n goes to infinity, taking the highest powers from the numerator. So I have 64n times another n times a 2n. So 64n cubed, oops, I forgot the 2. And then all over 6n cubed. So the n cubes cancel, and I can see a 2 cancels, so I get a 64 over a 3. All right. So taking baby steps, so I'm moving now from this sum, so I'll be using the sum formulas from the previous page, and then I'll be taking the limit, so taking one step at a time. So let's just start with the sum. So this sum right here, I'm going to pull this 2 over n on the outside, and I'm going to take this 2 over n times I minus 1. So I'm just doing a bunch of rewriting. Right, so this 2 and n, I made 2 over n here, and then times this I minus 1. So I'm going to pull this 2 over n on the outside, so I get 4 over n squared, summation of I minus 1. All right, so I see that I need to separate it around the subtraction. So 4 over n squared, summation of I, minus 4 over n squared, summation of 1. Both of these are from I equal 1 to n. Okay, so here's where I get to use my nifty formula for this. So that's n times n plus 1 divided by 2. And I'm carrying along my 4 over n squared. And then minus 4 over n. And then adding up 1 n times, that will be n. All right, so let's bring up what I've got here. So I'm going to be I'm pulling back the limit, right? Limit as n goes to infinity. And I'm going to put this in. So let me do it without any simplifying it first, so you can just see what I'm carrying along. So minus 4n over n. Okay, so I'm taking the limit of all of that. So let's cancel a little bit what I've got. So I've got a little bit of a 2 canceling here, right? So 2n, n plus 1 over n squared. And then minus, the n's canceled, so I'd get a minus of 4. All right, so now taking highest powers, because I can, because I've got limits with infinity, I get 2n squared over n squared minus 4. The n squareds cancel, so I get 2 minus 4, or negative 2. All right, so stepping it up a little bit. Oh, I've got something squared in here. All right, so let's play with the sum at first. So the sum, what's all here, I'm going to take the time to pull the 3 over n on the outside, and I'll just write it here for a second. Then I'm going to multiply this out. So I get 1 plus 6i over n plus 9i squared over n squared. Okay, so this 3 over n, I'm going to keep it all on the outside, and let's just split this up. So the summation of 1 plus 6 over n, the summation of I, plus 9 over n squared, the summation of I squared. Okay, so 3 over n. So this is adding up 1 n times, so that's n, plus 6 over n. This is n times n plus 1 divided by 2, plus 9 over n squared, and I don't think we've used this one yet, so let's go back up and look at it. So the summation of I squared is this, n times n plus 1, 2n plus 1 over 6. N times n plus 1, 2n plus 1, all over 6. Okay. So let's distribute this 3 over n inside. So this times this gives me a 3. This multiplied in gives me 18n, n plus 1 over 2n squared. And I could probably cancel a little more. I'm just going slow so I don't make a mistake. Plus, this will give me a 27 over n cubed, n times n plus 1 all over 2n plus 1 all over a 6. All right, so what does this give me? 3 plus 9. One of the n's cancels, so I get n plus 1 over an n plus, okay, so I've got a 3 in common here, so I get a 9 halves. 9 halves, n times n plus 1, 2n plus 1, all over an n cubed. Okay, so now what I'm going to do is I'm going to take the time to put the limit in. So let me bring it up here. So I'm going to be taking the limit as n goes to infinity of this, right? 3, 9, n plus 1, all over n, plus 9 halves. I guess one of these n's could cancel, right? So 9 halves, n plus 1, 2n plus 1, all over an n squared. Okay, taking highest powers, well, limit as n goes to infinity, there's no n's there, so that's just 3, plus highest powers here would give me a 9n over an n, because I'm just taking highest powers, right? Highest powers. And then plus 9 halves. So going in to take highest powers from the numerator will be n times 2n. So that's 2n squared over an n squared. So let's cancel, go to the next step. So I get 3 plus 9 plus 9. 18 and 3 is 21.